Assalamualaikum. Hi guys. This video we will focus about the chemical properties of carbonyl compounds, which specifically about the chemical tests. There are a few chemical tests that you have to understand so that you can distinguish between carbonyl compounds with other class of compounds. The identification test for carbonyl compounds, we have 6 of them. The first one is Bradys Test, Tollens Test, Iodoform Test, Benedicts Test, Benedicts Test, and Schiff's Test. So all of these, you have to know the name of the test, write and spell the name of the test correctly, and after that, you should know how to write the equation for positive and negative result. And last but not least, what is the observation for positive and negative results? Let's focus with Bradys Test first. So this is the reaction of condensation with 2,4-dinitrophenylhydrazine, 2,4-DNPH. So this is our reagent, and usually you use acidic condition, H3O+ as well, so that you can identify the presence of carbonyl group in the compound. So the name of the test is Bradys Test, and this is the reagent that I mentioned before. When the question asks you about state the reagents, you have to write the full name. And when you write the equation, you have to write the structure for 2,4-DNPH. And this is where you got ketone or aldehyde, and make sure you put the acidic condition, and then you will form the condensation reaction, which you have to take up oxygen from the carbonyl carbon and H2 from hydrazine part. So these two is going to combine to form H2O. That's why this reaction is condensation, and the rest of it you are going to combine them as a big molecule. So this big molecule can show you how the orange precipitate form. So this is your observation, and this is one of the examples experiment for Bradys Test. You can see orange precipitate form in the boiling tube. Let's try example 15a. So as I mentioned before, take out oxygen from the carbonyl carbon and H2 from the hydrazine part. So we are going to combine everything and plus with water. So I'm going to start from the carbon, and then we have double bond attached to nitrogen, and this carbon we have hydrogen, 2 of it, and then this nitrogen you attach with another nitrogen, this one, and then this one got 1 hydrogen, and then attached to the benzene ring, this is our phenyl. Make sure you draw it correctly, and then you have NO2 at the second carbon attached and bonded to nitrogen, okay? And then another one more at the 4th carbon. And then don't forget you got H2O as the side product. So this is how you draw your structure. You can see the numbering for this one, 1, 2, 3, 4. Okay? So the observation for this reaction, orange precipitate form, and you got aldehyde. Next one we have ketone. So this ketone, I'm going to undergo the Bradys test so that I can identify the carbonyl compound. So what we are going to do, oxygen from carbonyl carbon and H2 from hydrazine, combine everything. So you got your product. This is our orange precipitate, and you got also water as the side product. So both aldehydes and ketones can show the positive result for Bradys test. Next one is Tollens test. Make sure you're spelling apostrophe behind S. And then this is where your reagent is AgNH3 2+ in hydroxide ion, and the product that you will form is carboxylic ion and silver. So what is the purpose for this chemical test? You are going to differentiate aldehyde from ketone. So it means that only aldehyde can show positive result for Tollens test. So in this part, you can also understand from the writing in the question, sometimes they will use the term Tollens reagent, or it can also refer to the aqueous silver nitrate and NH3 mixture, because you got this mixture. And also another term or sentence that will show you about the tolerance test, they can also use the sentence ammoniacal silver nitrate solution. So all of these are referring to the same tolerance reagent. And then when you write the equation, make sure you know how to write, and don't forget the square bracket and then charge positive. And then above the arrow is OH minus. So what will happen, you are going to form carboxylate ion where you got C double bond O, single bond O minus, and O minus is negative charge. It will attract positive charge from our reagents here, which is NH4+. And then don't forget you got silver solid. Either you want to show by using face, or you want to show it by using arrow pointing downwards, whichever is fine. Choose one of it. So the observation is coming from this formation of product, which is silver mirror form. Or if you cannot see the silver mirror like this, sometimes we can also accept gray precipitate form. So when writing the equation for ketone, as we know that it cannot be oxidized because ketone doesn't have any reducing hydrogen. So that is why when you undergo oxidation with tolerance reagent, you will not form any products at this side. And then make sure you use no observable changes, and the observation should be opposite to it. So let's try example 16. We have two examples here. So I'm going to show you how to form the carboxylate salt and silver from aldehyde. So we are going to change this hydrogen into O minus NH4+. So we are going to draw my structure. From here we got the ring in 5 carbon, and then you got carbon double bond O, and then O minus, and then it will attract NH4+. And last but not least, don't forget your silver, which is pointing downward, or if you want to put as solid, also acceptable. So you will have silver mirror form for this aldehyde. However, for ketone, as we know, there is no reducing hydrogen here. So what will happen? No silver mirror form as the observation, and your equation you should put no observable changes. So make sure you write the correct observation and correct equation. Next, we have iodoform test. Iodoform test for this part is similar to the iodoform test that you've learned in chapter alcohol. So the reagent is same, iodine in NaO or OH minus, and the observation also same. You will have light yellow precipitate form. This chemical test is to identify the alcohols that contain methyl carbonyl group. This is what you've learned in chapter 8. However, you also can use the same test to identify the carbonyl compounds that contain methyl ketone group. So what does it mean by methyl ketone group? For example, this one, I have C double bond O and bonded to methyl, and it must be this one, okay, the one that I square the shape. So this is what is referring to the methyl ketone group, or another same term, methyl carbonyl group. So you can see the difference between methyl carbonyl group and methyl ketone group. So both of these, if you got them in the structure of the compound given, they can show the positive result for iodoform test. So the general equation, if you use I2 in NaO, you will have carboxylate salt, attract Na+ as well, and Chi. Choose either two, whether in face solid or arrow pointing downwards. And then same goes, if you use I2 but now only OH minus, you will have carboxylate salt only without metal ion attract to it. And then Chi is needed because Chi is the product that show yellow precipitate form. So let's try a few examples. As I mentioned before, because this is iodoform test for carbonyl compound, so you have to make sure that carbonyl compounds contain methyl ketone group. Tapi tidaklah semestinya ia hanya adalah ketone sahaja. Kita perlu lihat contoh macam saya dah identify tadi. You have to know how to identify the methyl ketone group. So for ethanol, we have hydrogen attached to the carbonyl carbon at one side, and ethanol got 2 carbon atoms. You can see that this one is what we call as methyl ketone group. So ethanol is the only aldehyde that can show positive result for iodoform test. So of course this one we can show the product side, which is our carboxylate salt. So for this part we use NaOH. So I'm going to draw back. Let's say this is carbon first, this is carbon second. So we will start with carbon first. You can see at first carbon you have double bond O, and then you have hydrogen. So all of this akan kekal, tapi yang berubah adalah kawasan metil, di mana kawasan metil ni akan berubah menjadi O-, and then sebab kita pakai NaOH dia akan attract Na+. So this is how your carboxylate salt form, and then don't forget Chi as the side product. So you got your answer. So we can understand from here CH3 dekat sini change into O- Na+. Next, we try a few example more. We got 2 here. So this is our ketone. Make sure this ketone ada methyl carbonyl group ataupun methyl ketone group. So we got one here. And then what you can do, you can show the formation of carboxylate salt. So this is my carboxylate salt because I use only OH-, so tak adalah Na+. And then don't forget you have Chi as the side product. And this time I'm going to use arrow pointing downward, same thing. And then next one, we have also C ketone, but in this part our ketone, carbonyl carbon, we got 2 alkyl groups, but this alkyl groups is ethyl, so this is not methyl. So what happened? Can it do or undergo iodoform test? Of course no. So our equation we just only write no observable changes. So this is how it tests you whether you can recognize the methyl carbonyl group. Next one, we go for Fehling test. Fehling test will oxidize aldehyde and not ketones. So most of the tests usually positive result for aldehyde. So what can we see here? This is how we want to distinguish aliphatic. So the term here is very important. Aliphatic aldehyde from aromatic aldehyde and ketone. So what shows the positive result? Only aliphatic aldehyde. Maksudnya aldehyde yang attach kepada alkyl group dan hydrogen at the carbonyl carbon. So the reagents and conditions that you have to use, kalau dia minta awak state, awak kena tulis CO2+ dalam kurungan tartarate complex in OH-. So the product that you will form is copper 1 oxide dan juga carboxylate salt, and the observation should be brick red precipitate form. So dalam reaction ini awak boleh nampak sebenarnya CO2+ akan reduce menjadi Cu+. So this is our general equation. You have aliphatic aldehyde as I mentioned before, and then bila tulis equation awak just perlu tulis CO2+ complex. Dan kita patut tahu warna copper 2+ here is blue solution. And don't forget OH- on the top of the arrow. You will get carboxylate salt and Cu2O, solid. So this solid is what we are referring to the brick red precipitate. So for example, I got my aliphatic aldehyde mixed with Fehling solution, which is our blue solution. After a while, it will form brick red precipitate here. So you should realize that this one shows the positive result for Fehling test. Next one, we also got Benedicts Test. This is how you want to distinguish the same thing as Fehling test. You want to distinguish aliphatic aldehyde from aromatic aldehyde and ketone. However, the reagent used here is CO2+, but citrate complex. So yang ini yang berubah. Tadi tartrate, sekarang dia citrate complex. And then produk dan observation dia sama sahaja macam Fehling's test, iaitu brick red precipitate form dalam Fehling solution. So let's try this example. I have aliphatic aldehyde. So apa yang kita akan buat kalau aliphatic aldehyde, dia memang akan hasilkan positive result. Saya akan dapatkan carboxylate ion. So yang berubah tempat menjadi O- adalah hydrogen here. So I'm going to show my product C double bond O and then attach to CH3, and then we have O- here. And then don't forget your side product, which is Cu2O, and this is solid. So you change the position here from hydrogen, you got O- here. So this is our carboxylate ion ataupun carboxylate salt. Next one, untuk aromatic aldehyde, because we know that aromatic aldehyde will not show the positive result for Fehling's test. So I'm going to put my product as no observable changes. So observation untuk this one, no brick red precipitate form. Next, kita try another two more. So apa yang saya ada adalah ketone. So as I mentioned before, ketone juga tidak akan menunjukkan positive result, so dia akan tulis sebagai no observable changes. And the last one, kita ada D, iaitu aliphatic aldehyde. Cuma sekarang alkyl group saya adalah dalam bentuk ring. So this is my alkyl group. As I mentioned before, the one that change adalah H dekat aldehyde. So awak akan dapat structure yang sama, just copy it back. So C double bond O, and then you bond it with 5 carbon atoms in the ring, and then it becomes O-, and then plus Cu2O, and this is our precipitate, which is brick red precipitate. So you got your structure. So let's go with the last chemical test, which is Schiff's test. So this is the purpose you want to distinguish aldehyde from ketone as well. So hanya aldehyde yang akan hasilkan positive result, iaitu pinkish purple ataupun magenta solution. So ketone akan memberikan negative result untuk Schiff's test. So let's say this one, you can see that colorless, it stay colorless. Maknanya kita boleh anggap aldehyde is absent. There is no aldehyde in this solution. However, kalau kita dapat magenta ataupun any chrome of colors here, okay, similarity saya dah tunjuk, awak akan boleh conclude aldehyde is present in this solution. One requirement that you have to know for your syllabus, you don't have to write the equation for Schiff's reagent and equation. It is not required. So bila awak tulis, awak just tulis untuk aldehyde, awak plus atas anak panah ni awak tulis Schiff's reagent, terus tulis bahagian produk pinkish purple solution. Maknanya kita boleh faham awak dah bagi tahu formation of pinkish purple solution as the product. However, untuk ketone, there is no observable changes when reacts with Schiff's reagent. Before we end our video, I got a summary of oxidation test yang kita ada dalam chapter, especially untuk carbonyl compounds. Awak ada KMNO4, dichromate, and awak ada tolerance test, and then Schiff's, dan juga Fehling's and Benedicts. Seterusnya awak ada iodoform. So pastikan awak tulis equation dengan betul dan awak tahu purpose untuk setiap chemical test yang kita buat. Except for oxidation, this is not chemical test. This is only reaction. Tapi dia hasilkan observation juga. And then yang mana satu boleh show positive and negative result, you should take a look properly. This is only the summary and you can revise and use this one as a reference when doing the exercise. So I believe that's all from me. I hope you are clear how the chemical test form, especially the equation for the chemical test, and try to do a lot of practices. And that's it from me. I will see you in the next video. Bye.